Hi everyone. Yesterday we learned about how we write an equation using point-slope form. And so today we're going to talk about how we graph an equation if we're given that equation in point-slope form. What I want to do before we get into that is talk a little bit about why we even need point-slope form in the first place. So prior to learning point-slope form, we always graphed our equations using slope-intercept form. And we know that slope-intercept form is going to be our old y equals mx plus b. So we know how to graph equations that are in that form. So we could potentially say, well, I'm just going to rearrange this equation to get y by itself, and then I'll graph it using slope-intercept form. So if we were going to do that, if you think back to chapter 1, the first thing we would have to do before we start solving is to distribute a -3/5 to both of those terms in the parentheses so that I could get rid of the parentheses. So a -3/5 times x gives us a -3/5 x. If I type in -3/5 times a +4 into my calculator, I'm going to get a -12/5. So far I've gotten rid of the parentheses, which is good. On the left side I have y minus 2. So now to isolate y, to get that all by itself, I'm going to add 2 to both sides. Now I could use my calculator to get that. I've isolated the y, I've got -3/5 x, and then I'm going to do -12/5 plus 2, which is going to give me -2/5. So now I've met my goal now of getting this in slope-intercept form, but if we think about how we use this equation actually isn't that helpful because now our y-intercept, right, that's our b value or our y-intercept, that's a -2/5. So that's not a really helpful y-intercept to plot on the graph because we'd have to do estimating and then we could have a line that's not that accurate. So that's why we're going to use point-slope form. So here's where I want to jump back a minute. Now remember, point-slope form, we used this yesterday, and we learned that point-slope form is y minus y1 equals m times the quantity x minus x1. So here I'm going to flip back a page to yesterday's notes. And I want to let's look at this first example. So in yesterday's notes, we were given a point and a slope, and we had to write it in point-slope form. Here's what I want you to notice. When we have an equation in point-slope form, we can find our y value here. But if I compare this number to what was my original y value, you'll notice that those have opposite signs. So what was a -3 in our point became a +3 because we were subtracting a negative. Same thing with my x value. My original x was a +4. In my equation, it looks like a -4 because we're subtracting it. So we have to realize that whatever we see in point-slope form, our original coordinate had the opposite signs. So let's take a look back at what that means for us now. If I know this is point-slope form, right, I'm looking to get out of here. I know I can get a point, and I know I can get a slope. Well, the slope is the easy part. We know the slope is our m, what's in front of our parentheses. So in our case, our slope is -3/5. Now, I also need a point, so I need some x and y coordinates. Now, again, this x, it looks like it's a +4, but I know I need the opposite sign, so my point is going to have an x coordinate of -4. Same thing when I go for my y coordinate. This looks like a -2, So I'm going to take the opposite sign, and my point is going to have a y-coordinate that's positive. So I'm going to make us a note here that our x and y coordinates are opposite from how they appear in the equation. And again, what I mean by that is when we were looking at our x-coordinate, it looks like a positive 4, but in our point, it's actually a negative 4. Okay. So now I know a point and I have my slope. So now our job is to graph it. When we're graphing from point-slope form, the first thing we're going to do is we're going to graph the point that we found. So in our case, we're going to plot a negative 4, comma 2, and then we're going to use our slope to locate a new point. So in this case, my slope is negative 3/5, so I'm going to go down 3 and right 5. And so then I can I can connect these 2 points, and I should be using a straight edge here. And I've got the graph of my line. So kind of like before how we started with our y-intercept, now we're starting with our point, and our slope still give us the directions to find the next point on the line. All right, let's do a couple more. So for number 1, my equation is y plus 2 equals 2/3 times the quantity x minus 3. And again, I know this comes from y minus y1 equals m times the quantity x minus x1. And I know to graph it, I need 2 things. I need a point, and I need a slope. So my slope is always going to be the m. Again, it's that number that's in front of my parentheses. So my slope is 2/3. My point, well, the x-coordinate is going to come from here. Now, this looks like a negative 3, which means my point is going to have an x-coordinate of positive 3. My y is going to come from here. This looks like a positive 2, which means my y-coordinate is a negative 2. So now to graph that, we're going to start by plotting the point. So I have 3, negative 2. I have a positive slope of 2/3, so I'm going to rise 2 and run 3. And that gives me the graph of my line. Okay. I am going to save number 2. A lot of people mentioned that it might be helpful to go over examples in class before we start work. So I'll save number 2 to go over at the start of class. Let's go down and take a look at number 3. I'm going to adjust the camera here. Okay. Now, in number 3, it says to write an equation in point-slope form that passes through the given points. Now again, I'm going to flip back and show you. That's just exactly what we were doing. Actually, I guess we haven't done these yet. Yesterday, we had a point and a slope. Now what we've got is just 2 points, so we actually have a little more work to do. So in this case, I don't yet have the slope. I know if I'm going to write in point-slope form, I need a point and a slope. So the first thing I'm going to have to do is find the slope between these 2 points. So I know I'm going to need my slope formula. So I know that m is equal to y2 minus y1, so 6 minus 4, over x2 minus x1, which is 17 minus 9. So if I simplify, I get 2 over, let's see, 8, which gives me 1/4. So now I've got my slope, my m, and I've got a point. So let's put that in point slope form. My equation is going to be y minus y1, which is 4, equals my slope times x minus x1, which is 9. Now, the second piece is asking us to rearrange to get the equation in slope-intercept form. If I need to do that, I need to get y all by itself. So I'm going to write my equation again. And I'm going to go through my steps to isolate y. So the first thing I'm going to do is I'm going to distribute the 1/4. So this is going to be 1/4 x minus 9/4. That's y minus 4. My next step is going to be to add 4. And I'm sorry, I'm going to have to move this over here. So this is going to cancel. I'm going to get y equals 1/4 x. Now, I highly recommend using your calculator here. So if you type in a negative 9/4 plus 4, you should get plus, let's see, plus 7/4. And so my equation in slope-intercept form is 1/4 x plus 7/4. So these two equations, my point slope form and my slope-intercept form, if I were to graph those two equations, they would give me the exact same line, but this one's going to be easier to graph because I don't have the y-intercept that's a fraction. So we'll go ahead and again, we'll save number 4. So we'll do number 2 and 4 in class then before you start your practice. All right, see you back in class.